Have you ever wondered about the potential of stem cells in medical advancements? Stem cells, these remarkable entities, are not your average cells. They are undifferentiated, meaning they haven't decided what they want to be when they grow up. They're the undecided majors of the cellular world. But this undecided status holds an incredible power, the power to transform into specialized cell types. You could say they're the shapeshifters of the biological realm, able to assume the role of heart cells, brain cells, skin cells, or essentially any type of cell in the body. There are two main kinds of these cellular shapeshifters: embryonic stem cells, often abbreviated as ESCs, and adult stem cells, or ASCs for short. Embryonic stem cells come from, you guessed it, embryos. Specifically, these cells are harvested from 3 to 5-day-old embryos. At this stage, an embryo is called a blastocyst and contains around 150 cells. These are pluripotent stem cells, meaning they can turn into more than 200 different cell types in the body. On the other hand, adult stem cells are found in various tissues throughout the body. These include bone marrow, blood vessels, the brain, and even the heart. Unlike their embryonic counterparts, adult stem cells are multipotent. This means they can transform into a limited number of cell types related to their tissue of origin. But why does this matter? Why are we so interested in these cellular shapeshifters? Well, it's because they hold the potential to revolutionize the field of medicine. Imagine being able to repair damaged tissues and organs, treat debilitating diseases, and even create artificial organs for transplantation. The possibilities are truly staggering, but it's not all smooth sailing. The use of stem cells, especially embryonic stem cells, raises several ethical and practical concerns. There are potential issues like tumor formation and immune rejection that need to be addressed. Despite these challenges, the power of stem cells cannot be overstated. Ongoing research is continually expanding our understanding, making these cellular shapeshifters a promising avenue for medical advancements. Stem cells, with their transformative abilities, offer a world of potential in the medical field. Stem cells hold remarkable benefits in the realm of medicine. These unsung heroes of our bodies, with their unique ability to morph into specialized cell types, are revolutionizing the field of medicine in ways we could only dream of a few decades ago. Let's dive into the plethora of benefits stem cells offer. First up is regenerative medicine, a field that's seeing a paradigm shift thanks to stem cells. These cells can repair damaged or diseased tissues and organs, offering new possibilities for treatment. Imagine the human heart, once damaged, could heal itself, or neurodegenerative disorders like Parkinson's or Alzheimer's could be silenced. Even conditions like diabetes and spinal cord injuries could be treated more effectively, all thanks to the transformative power of stem cells. Next, we move to the realm of drug testing. Before a new drug hits the market, it undergoes rigorous testing. Stem cells can be used to evaluate a drug's safety and efficacy before it reaches human trials. This not only speeds up the drug development process, but also makes it safer and more reliable. Understanding diseases at a deeper level is another significant benefit of stem cells. They allow scientists to study disease development and progression, helping us identify genetic and molecular mechanisms at play. This knowledge is crucial in developing targeted treatments and potentially preventing diseases altogether. Cell-based therapies are another promising application of stem cells. They're being used to investigate treatments for blood disorders, autoimmune diseases, and certain cancers. These therapies could mean the difference between life and death for many patients. Tissue engineering is yet another field where stem cells are making a significant impact. Using stem cells, scientists can create artificial tissues and organs for transplantation. This could potentially eliminate the long waiting lists for organ transplants and the risk of organ rejection. Speaking of transplants, stem cells are also being used to treat blood disorders such as leukemia. Hematopoietic stem cells, found in bone marrow, can be transplanted to replenish the patient's blood cells, offering a new lease on life. Finally, stem cells offer an alternative to organ transplants. By engineering tissues from a patient's own stem cells, we can reduce our reliance on organ transplants and the associated risks. This could revolutionize organ transplantation, making it safer and more accessible. In summary, from regenerative medicine to organ transplants, stem cells are ushering in a new era of medical treatments and advancements. They offer promising solutions to some of our most pressing medical challenges, enabling us to treat diseases more effectively and even potentially prevent them. These benefits make stem cells an invaluable tool in modern medical treatments and advancements. Their transformative power holds the potential to change the face of medicine as we know it, offering hope for a healthier, brighter future. Despite the incredible benefits, stem cells also present certain challenges. Let's delve into the complexities of stem cell research and use. One of the most heated debates revolves around the use of embryonic stem cells. These cells are often sourced from leftover embryos in fertility clinics, and their use raises ethical questions. Some argue that because these embryos could potentially develop into a human being, using them for research is morally unacceptable. On the other hand, proponents of embryonic stem cell research argue that these embryos, which are often discarded if not used for research, could provide invaluable insights into disease and potential treatments. This ethical tug-of-war has resulted in a complex landscape of regulations and restrictions around embryonic stem cell research. Beyond the ethical concerns, there are also biological challenges to consider. For instance, when stem cells are used in regenerative medicine, there's a potential risk of tumor formation. This is because stem cells are essentially blank slates, and while they have the potential to develop into any cell type, they could potentially also develop into cancerous cells. Another significant hurdle is the issue of immune rejection. This is especially pertinent in the case of organ transplantation. If stem cells from a donor are used to grow a new organ for a patient, there's a risk that the patient's body will recognize the new organ as foreign and launch an immune response against it. These challenges are not to be taken lightly, and researchers are continually working to address them. For instance, they're developing techniques to reprogram adult cells into a stem cell-like state, potentially bypassing the ethical concerns associated with embryonic stem cells. They're also exploring ways to modify the immune response to reduce the risk of rejection in transplants. These challenges, while significant, are an integral part of the ongoing research and understanding of stem cells. It's a testament to the field's commitment to ensuring that the tremendous potential of stem cells can be harnessed in a safe and ethical manner. Stem cells, as we've seen, are a powerful tool in the medical field. They embody the extraordinary potential to transform into specialized cell types, offering a glimpse into the future of medicine. There are two main types of stem cells, each with unique characteristics and applications. Embryonic stem cells, or ESCs, originate from embryos and hold the potential to develop into any cell type in the body. Adult stem cells, on the other hand, are found in various tissues and can replenish cells within their specific tissue type. Stem cells are at the heart of regenerative medicine, with the ability to repair damaged or diseased tissues and organs. They offer hope for treating conditions such as heart disease, neurodegenerative disorders, diabetes, and spinal cord injuries. Beyond this, they present opportunities in drug testing, allowing for the evaluation of drug safety and efficacy before human trials. In addition to these applications, stem cells provide a unique window into understanding disease development and progression, helping uncover the genetic and molecular mechanisms at play. They are also pivotal in developing cell-based therapies for blood disorders, autoimmune diseases, and certain cancers. The field of tissue engineering leverages stem cells to create artificial tissues and organs for transplantation. This could potentially reduce our reliance on organ transplants. Moreover, hematopoietic stem cells are already being used to treat blood disorders like leukemia through bone marrow transplants. However, the journey to harness the full potential of stem cells is not without challenges. Ethical concerns, especially around the use of embryonic stem cells, remain a point of contention. Moreover, there are potential issues like tumor formation and immune rejection in therapeutic applications that need to be addressed. Yet, despite these challenges, ongoing research is expanding our understanding and paving the way to overcome these hurdles. With every new discovery, we inch closer to unlocking the full potential of these remarkable cells. With ongoing research, stem cells continue to offer a promising avenue for medical advancements, revolutionizing the way we approach health and disease.